So to start with, to find the critical points, I need a 0 on the right side. So I'm going to move the 5x over, and that becomes 1/2 plus 12 over x squared minus 5 over x has to be greater than 0. So in order to find the critical points, I'm looking for where is the entire thing equal to 0, which means I need one fraction. And in order to add fractions, I need a common denominator. So my common denominator is 2x squared. And I take a look at each fraction to see how I need to adjust. This one needs to be multiplied by x squared over x squared. The second one needs to be just multiplied by a 2. So that's 24. And the last one needs to be multiplied by a 2x. So then we've got 10x. So now writing that as one fraction, I have 2x squared over x squared. In the numerator, I've got x squared plus 24 minus 10x. Where is that equal to 0? I'm going to rearrange the numerator so that it's in descending order, so it's easier to recognize if I can factor that or not. So as far as critical points go, where is the denominator equal to 0? So that's where x squared equals 0. In other words, when x is 0. So there's one critical point. The other one occurs when x squared minus 10x plus 24 equals 0. That one is factorable. It's when x minus 6 and x minus 4 equals 0, because negative 6 times negative 4 is positive 24, and negative 6 plus negative 4 is negative 10. So I have two roots. One is when x equals 6, the other one is when x equals 4. And so I've got three critical points. I've got one at 0, one at 4, and one at 6. And all of these are going to be hollow dots because the first one is where the denominator is 0, and the other two are where the numerator is 0, but because this doesn't include an equal sign, we don't want it to actually equal 0. So that divides the number line into 4 sections. And so I am going to test points. Here I'm going to test x equals -1, and I'm going to test it in the original. So 1/2 plus 12 over -1 squared, is that greater than 5 over -1? So that's 1/2 plus 12, is that greater than -5? Well, I think that you don't even need to do the common denominator and adding the fractions. You can see this is a positive number, and it's definitely going to be greater than -5, so this area is true. In the next section, I'm going to test x equals 1, and I do it again. So that's 1/2 plus 12 over 1 squared, which is 12 over 1. Is that greater than 5 over 1? So this is 1/2 plus 12. Is that greater than 5? Well, 12 plus 1/2 is definitely bigger than 5, so yes, this works as well. Now I'm moving into the third section, which is test x equals 5. And I have 1/2 plus 12 over 25. Is that greater than 5 over 5? So 1/2 plus 12 over 25, is that greater than 1? So if I write this as a common denominator, I have 25 over 50 plus 24 over 50, which is 49 over 50. And is that greater than 1? No, that's false, so it does not work in this section. And then in the last section, I'm going to test x equals 10. I take 10 because often 10 is an easy one to calculate with. 1/2 plus 12 over 10 squared, which is 100. Is that greater than 5 over 10? So 5 over 10, 1/2 plus 12 over 100. If I find a common denominator, that's 50 over 100 plus 12 over 100. Is that greater than 50 over 100? You bet it is, because these are the same. So if you're adding anything to 50 over 100, it's bigger. So we've got that section too, which means our final answer is going to be this section, and this section. And if I write that now in interval notation, the first one starts at -infinity, goes to 0. The second one starts at 0 and goes to 4. And the last one starts at 6 and goes to infinity.